Okay.
All right, we're recording this session. This is our fourth webcast for Algebra 1 for associate degree programs. And I'm switching over to your instructor, Karen. Hold on a sec.
Again, I want to say good morning to everybody while Miss Jelena is setting that up. We have, while she's doing that, I want to say that submitting your homework should be a little easier now. We've kind of increased the number of files you can upload, so it should be quite easier. And you also have the option to type in text on there too.
So it should be ready now.
That should help solve some issues. So
great. I'm muting myself out. You can take over. Thank you, Karen.
Great. So, okay. So today what we're looking at, it would be solving inequalities. This is going to be what's coming up this week for your homework. Okay. And if at any point you can't hear me, let me know, you guys. So when we go to solve inequalities, let me put my notes back on the first page. I was looking at my notes before. Okay. I want to warm you guys up, because the reason I'm going to choose this example is solving an equation is because when you go to solve an inequality, it's very similar. There's a couple of little exceptions to that statement, but we're going to go over that. So let's warm up, shall we? Let's see. Let me go ahead and grab this problem. Okay, let's have just a warm up. Okay, so my directions will read solve the equation, okay, or just solve. That's fine too. And I want to put negative 5x minus 10 is equal to, okay, 3x plus 1. Okay, oh, excuse me, I put a 10, not 10, just 1. Okay, just 3x plus 1. Thanks, guys. Okay, so what we want to do, of course, we want to take each individual side. We're not doing any switching of the sides thing yet. We want to take each side of this equation and we simplify it typically, right? So let's go through that. Okay, so let's take the negative 5 and we want to distribute it thoroughly into whatever's in the parentheses. Okay, so this guy's going to go here and here. Okay, so negative 5 times x is negative 5x. Now negative 5 times a negative 10 will be a positive 50. Okay, and so we're going to carry down this equal sign. We're going to carry down the right side because the right side is simplified already. Now here's the point when we start using our properties of equality to get x on one side and the constant terms on the other side. Right? Remember, the goal is always to isolate x on its own side of the equation. Okay, so what I'm going to do first is I'm going to move the 50. So let's get our constant terms onto the right side. So if I subtract 50 from both sides, when I put it on the other side, I'm putting it under the term it's going to coincide with. You know, it's going to combine to the 1, so I'll put it there. It cancels here. We have negative 5x, and then we have 3x, minus 49 on the right. Okay. Now, the next thing I want to do is I want to get the x terms over to the left. So I'm going to subtract. See, 3x is positive, so I'll subtract from both sides that value. Negative 3x. Okay, and it makes it cancel here. And it pops up on the other side, and I can combine it with the like term, the other x term. So I end up with negative x, negative 8x equal to negative 49. And now we want, ultimately now, x by itself. Now here's the deal. I want to divide by whatever's attached to that x, right? And it's a negative 8. Okay. Alrighty, so I'm going to cancel here. And now x is equal to what? A positive 49 over 8. So 49 eighths. And 49 only has factors of 7. 8 has factors of 2 prime factors, right? And these, so there's no common factors to reduce by, so I am done. Okay. So here we go. Done. Okay, so the reason I chose this is all the steps we just did pretty much are going to be the same when we do an inequality, except for the last step when I divided by a negative number. And I'll get into that in a minute, okay? So that's going to make our inequality sign switch. First, I want to talk about what is an inequality sign, okay? Okay, so let's kind of partition this off. Let's kind of get that over here. Now, let's talk about inequality symbols. All right, so some of the things you're going to see, okay? So when you look, let me just talk about the anatomy, okay? Let's put it that way. The anatomy, since we're all medical related field students, anatomy of an inequality symbol. Okay, so here's a giant inequality symbol, okay? So notice I'm going to put the word big here. I know this is very elementary, but just bear with me. And so little or small here. Okay, the inequality symbol is a directional symbol. And when I was a kid, I had a teacher who really helped us out, and he taught us that we could, you know, I'm in Louisiana, right? So we could think of it as an alligator's mouth, and the alligator's really hungry, and he wants to eat what's more, right? Okay. So the guy's wanting to, this little alligator guy, he's looking at the bigger chunk that he wants to chomp off of, okay? So this part is always facing the larger number, okay? And the what looks like an arrow point is always facing the smaller value. Okay, so in other words, we could say 5 is larger than 1. Okay, now included in all these inequality symbols, the types you're going to see greater than, which is what you've just seen. So, and we read it from left to right. So box, empty box, box, see. So this is a greater than symbol. This is greater than. Now if you would see a greater than, looks like it's a halfway open one, and it has what looks like the bottom part of an equal sign. This is greater than or equal to. Okay, so for greater than, well, I'll come back and do that. We can also have, let me finish these, less than, and of course it's supposed to be an E. We can have less than or equal to. Okay, so some examples of that. If I have, let's see, if I have x is greater than or equal to 5, okay, for example, where is this on a number line, okay? So if I put a number line here, I'm going to center it at 5, okay? Here's 4 on the left, 6 on the right. Now, this is, x is, we would shade towards wherever the alligator's trying to munch out, okay? So we want to shave greater than 5. So here are my values greater than 5. Okay? And the or equal to symbol is telling us what to do with the 5. It's telling us to include the 5. And what you'll see would be a bracket, a squared off bracket. This will include the 5. In other books you may see Also, you could see a closed circle, a closed-in dot. Okay, if I had just x greater than 5, okay, right above that, let's put our 5 here, 4 here, 6 here. I'm right above this example here, up here. Of course, we're still going to shade in greater than 5, excuse me. Okay, you're still shading greater than 5. My little slash, my pen's kind of doing funny things again. So, shading greater than 5. I got to put that back. Sorry, guys. And instead of a bracket, a squared off bracket, you're wanting to use a parenthesis. Okay, a parenthesis. So here we have a bracket. We'll include that endpoint of 5, a parenthesis, and shade it in the area that the solution exists in. That will include the 5 and or include or exclude, and then the interval where the solution lies is what's shaded. Okay, that similarly you do that for less than and less than or equal to, except it would be to the left, right? I'm going to do more of this where we graph it in the solutions when we come to our solutions. Okay, so let me get to more about the solving of the inequalities. Okay, that's example for later that you're seeing pop up there. Okay, so here we go. Let's see. Hold on, give me a sec. Let me get this pop up. Okay, go further. Thank you. All right, now, so solving these things. Let's take a look. So how to solve. An inequality. Okay. Excuse me. So there's some properties, just like we had the properties of equality, we still want to have, these are similar to the properties of inequality. So if I have something to this effect, A is less than B, for example. Okay, so I'll say if A is less than B, then let's say I add the value of C to A. I still have to add that same value to the right, okay? Okay, and so the same goes for greater than. A is greater than B, then A plus C is still going to be greater than B plus C. Okay? Okay, notice I'm just talking about adding, and that would include subtraction too. So would I add or subtract to one side, I have to do that to the other. And now, the big one is this. If we are multiplying, here's the multiplication property for inequalities, okay? So here's the special one. Okay, let me separate this one off. So far everything's the same. You know, I haven't changed the inequality. An example of these, the ones I just showed you, would be this. For example, I'm going to say solve. If I have x minus 1 is less than 0, okay, I can add 1 to the left, and I'm going to add 1 to the right, okay, and it'll cancel here, and x is still less than. In other words, this is still the same. The inequality is still the same. X is less than. It's going in the same direction. Okay. All right, and so if I wanted to look at that solution graphically, less than 1, 0. You want to center it. On paper, you can center your number line at 1. Less than, I'll shade to the left. And notice it's not or equal to, it's just only less than, so it can't be 1. So I want to exclude that endpoint by using an open parenthesis in that direction. Another way, the other way we would do that would be to use an open circle. Okay, so that's two ways to show it graphically, either a parenthesis or an open circle. Okay. All right, and we're going to talk about something else too called interval notation, and I'm going to talk about that more in a sec, but the interval notation for this for future reference, when we finally do get to it, you can go back and look at this, is if it's less than 1, I'm coming up from negative infinity, right? This is a real number line. So I'll use a parenthesis coming up from negative infinity through 1. And again, same goes for the parenthesis or the bracket. You can use a parenthesis to cap it off at wherever the endpoint is. Parenthesis excludes, and a bracket, a squared off bracket, will include the endpoint. Did I say that right? Parenthesis will exclude, a bracket will include. Okay. So let's get into the multiplication part now, okay? So this is where we have to kind of be alert. Everything, as far as solving this, so far everything's the same as an equation, okay? So let's come here and say this. If, okay, let's see. All right, I'm trying to look at my notes. Okay, okay, if you multiply or divide. I'm going to put this in plain English for you because I think this is a more important one. This is where things would be different. If we multiply or divide both sides, now this has to be both sides of an equation, both sides of our inequality, excuse me, of an inequality by a negative value. The sign, the sense, what we call the sense of the inequality symbol. In other words, the sense is either greater than or less of direction. Okay, it's called the sense, but I'm just going to say direction. Okay, I'll put this in plain English. We swap the direction of the inequality, and I'm going to show you why in a sec with an example. Okay. Here's just an example. It's not solving, it's just a fact, okay? Our first fact, let's see. The fact that -1 is less than or equal to 0. And I'm using or equal to just to kind of, well, no, I don't want to confuse anybody. Let's just use less than for our example. Just use less than. -1 is less than 0. We all agree, right? Okay, so what if I want to multiply both sides of this by, say, a positive value, okay? So let's multiply both sides by, okay, and actually I'm going to make the next thing we'll have a label of A. The next part right here, A, by a positive, and I'm going to put a little positive symbol on it, +5. Okay, dot, dot, dot. All right, and so let me make some room. Okay, so let's take that -1, leave a little room, less than 0, leave a little room. So here we go. I'm going to take a +5 and multiply it. What I do to one side, I have to do to the other. Okay, so what now is this? This side will now be -5, and the right side is still 0. So is this still true? Yeah, still true. Okay, so I didn't swap. Remember, I multiplied by a positive value on both sides. So everything's the same. Okay, everything is still there. Okay. So now part B, let's multiply by a -5. Dot, dot, dot. Okay, so let's start out the way we did before. We're going to write our -1, leave a little room, less than 0, leave a little room. And I'm going to come back and plug in this -5. Okay? So -5 on the left, so I have to put -5 onto the right. Now let's see what happens here, okay? I'm not going to put this in. Let's wait to write the inequality symbol, okay? Let's see what happens on the left. Now my sign was negative, Now it's two negatives multiplied, and I'm going to have a positive value. So I'm going to have positive 5. And on the left, I'm going to still have 0. 0 times negative 5 is still 0. Now, look what happens, okay? Take a look at the inequality truthfulness, okay, I guess you could say. What happens from here to here? Which of these should the alligator be eating, in other words? The 5, right? Look. So when you multiply or divide both sides by a negative value, the direction of the inequality changes. Okay, so when you're solving, when you're in the process of solving an equation, here's what that looks like. Let me give you an example here. Okay, let me add a little writing room. Okay. Okay, so here's what it looks like. Let's have an example. We're going to go into lots of examples now. I'm going to show you different scenarios. Okay, so examples, solve the inequalities. And I'm going to show you different types of inequalities now. I think from this point on, teaching you through the examples is going to be the best thing. So here I'm going to keep it simple, okay? Let's kind of, I'm going to make a little bit of a compound problem for y'all though. Let's have negative 3x minus 1 is less than or equal to 7. Oh, okay. Okay, so wait, hold on a second. Okay, so here we are. Okay. So now we're going to do what? Well, first we're going to add 1 to both sides, right? Just as though this was an equal sign. You begin by adding off the constant, right? Cancels here. And on my right side, I have an 8. Keep that inequality sign facing the same way. Okay. Now at this point, I have to divide off what's attached to x. So what do I have to divide? I have to divide by a negative 3 on the left and the right. Right? Okay? So this is the point. Because of this, it makes a swap of direction here. Okay? So, alrighty. So my solution is x is greater than or equal to negative 8/3. Okay. And I can't reduce 8/3 or negative 8/3 any more than that. That's done. Okay, so let's look at the different ways you could be asked to answer this. Oh, yes, Constantin, yes, I got you. I saw your question, by the way. Okay, it's come. They're coming. All right. So here's the deal. Okay, quickly, let's look at these graphically. I can center this at negative 8/3, and or equal to means that I'm going to include negative 8/3 in my solution set. So I'm going to use a squared off bracket this time, not a parenthesis, and greater than shades to the right. Okie doke. Now, interval notation. The way we do our interval notation, okay, so this is graphical. All right, and let me give some room here. All right, hold on a second. There we go. All right. Interval notation looks like this. Not like that. Okay, my pen's making funny. It's rebelling. My pen likes to rebel. It's time for a new Wacom board. Interval notation looks like this. And you can look at your graphical. If you get good at the graphing part, the graphical solution, that will help you write your interval notation, okay? So again, same here, though, we're going to use the bracket for interval notation. And we read the interval notation from left to right, just like we read a graph or read period from left to right. So we're going to start at -8/3 and include it, comma, and what comes next is the maximum endpoint, or infinity. In this case, it's an open interval, so we go up to infinity. And the infinity sign will always have a parenthesis, by the way. Okay, we always put a parentheses on the infinities. Okay, side note really quickly about the interval notation. Let me put that here on the top here, just kind of up here next to where our directions were. To represent the set of real numbers, by the way, the real numbers with interval notation. So if you can represent it on a number line, you can use interval notation. So what is the whole number line? So you may come into something that has all real numbers for solutions, right? Here's 0, here's my negative values, here's my positives. And if I'm trying to represent them, I'll shade the entire number line, right? So where is that? This is negative infinity over here. Here's positive infinity. So we want to go from infinity to infinity. So negative infinity to positive infinity. This represents the entire set of real numbers. Negative infinity through positive infinity. Parentheses. Okay, that's what I'm trying to stress there. Okay, so that's in case you're asked for a domain, for example, something that there's no restrictions, nothing's taken away from the real numbers. That would be all real numbers included in what you could plug in. That would be your negative infinity to infinity. So you may have to use this symbol, this what I've written here at some point. So just kind of letting you know. All right, let me go through some other examples, and you'll get the hang of the interval notation, you know. Okay, Vivian's asking me, when you do your homework, should you give the 3 answers, graphical, interval, or inequality symbol? Of course you're going to do the inequality, because when you're going to get to the end of your solving, and you need to give me the x is greater than or equal to, or whatever. As far as graphical interval, it should be written in the homework, and I'm going to go double check that for you, Vivian, and I'll make sure, and let me answer that. I'll make sure I'll make that clear, like probably right after this, okay? I'll send y'all a post in the general forum or something, okay? All right, thanks for that. That's a good question. Anyway, okay, so let's go to B. Okay, let me get a sip of my drink. All right, so here's one. And again, you know, like last time, I want you guys to be trying to, you know, go along with me here and solve on your own. Go ahead of me while I explain stuff maybe, and test yourself. Some of you have had this before, and so I want you to work ahead if you can. Okay? 4x plus 7 greater than or equal to 2x minus 3. Okay. So here we go. Now, here we are, just like similar to the warm-up problem when we started today, you know, at the from the second set on. If you look here, okay, this would be similar solving from here on. You can tell I just used my mouse to do that instead of my pen. Sorry. So this step has the x and the constant on both sides, like this. So what we did from here on in this example is similar steps we're going to use in this inequality we're about to solve. And start by moving constants or variables, or we could just do both in one shot. So I could subtract 2x from both sides. You may want to keep doing 1, negative 3. Okay. And now we're going to subtract the 7 from both sides. Let's keep the scale greater than or equal to and negative 10. Okay? So now what do we do? Now what do? We divide by whatever's attached to x, right? And that in this case is the positive 2. So do that, and I have x equal to, let me swap back, excuse me, not equal to, greater than or equal to negative 5. Now be careful, a lot of times students get confused and they want to swap it because I'm dividing by a negative on the right. But that's not what I've brought into both sides. Both sides have been multiplied by a positive value of positive 2. Okay, so it's whatever you are doing, multiplying or dividing to both sides, and pretty much usually in this last step too. Okay, but we're good. It stays the same on this one. Okay. Now, for now, I'm going to give you all the graphical and interval notation, but I'm probably not always going to do that just for time's sake. So if you guys ever want to see it, the graphical or whichever one I do not get a chance to do, let me know. Greater than 5, shade to the right, and use a bracket to include. Negative 5. Shade here. Okay. All right. And then, of course, interval notation. You're just going to bracket negative 5 up through infinity, positive infinity. That's just an ugly little parenthesis I did there. Okay. There you go. All right, so now part C. Moving right along, and I got to watch the time, guys, so we're going to keep it to an hour today. Let me get you to another one. Now, these are just your run-of-the-mill inequalities that you'll solve. It's possible you could run into these compound inequalities, okay, and there's 2 types. All right, and I'm going to put that here in C, okay, compound inequalities. Okay, now let me come to the side here, and I'm going to make a little note, side note. Okay. Compound inequalities can come in a couple of forms, okay? So you could have this one. Oh, let me get my little thing. Hey, that page. Look at my page turned on me. Okay, there we are. Okay, so we can have what's called an interval. Oh, there you are. And I'm going to put forms. Okay, go back. Okay. Or format. For compound inequalities. And I'm going to abbreviate that. Okay, so here's what the solutions look like on the number line. I'm going to show you this. So if we have A and B on a number line, A and B are real numbers. That should be a B. Okay, so these any 2 real numbers, and A is going to be less than B. Okay, but my solution set X is going to be located here between A and B. Okay. All right, and let me go ahead and use a bracket. Go back. Come back to me. Okay, I'm going to use a bracket, so I'm going to include A and B in my solution. So bracket. All right, so here's my solution set. This is where X is. Okay. So here's what this will look like. You may have A is less than or equal to X, right? A is below X, or X is big. If you read this right to left, X is bigger than A. And then X is also smaller than B, or including B. It could also be equal to B. So this is an interval. We want to read these from left to right. I said you can read it from right to left, yes, but usually you want to try to read them from left to right. That way your smaller value is on the left, and you're going up to the bigger values towards the right. Okay, that will be a useful thing to remember what I just said there in the future. Okay, reading these from left to right can be quite crucial in helping you understand how to do these and remember how to go about it. Okay, and so the other compound inequality looks like this. Let me get this pen. Okay, all right, it will look quite the opposite. I have A and I have B. And the X values will be, this time I'm going to exclude the endpoints just to help you practice the parentheses versus a bracket thing. Now my X's can be below A or less than A. And X can be also above B, greater than B. I love that. It thinks I'm scratching it out. That's what's happening when it does that. So, okay. So let's write that out. X is less than A, and X is greater than B. Okay? So that's the other kind of case. Okay, and that's kind of the thing is, let's see. Give me a sec. Oh, we almost done. There's a couple more things, and I'm going to be ready to get you some examples going. Well, we're going to get examples going right now, though. See, I said that wrong. Let's do this one. If you have -1 less than or equal to 3 minus 5x over 2 is less than or equal to 9. Okay? So notice what I have written on the right, the format. This is also the format for the solution, okay, what your solution should look like. So look at the first format I wrote, where the x is between a and b. Okay? Notice in the problem I gave you, the x value is between a and b. It's between the outer limits, okay? And so this is where we want x to end up. Just like in an equation, we want x to end up on one side of the equal sign. In the compound inequality, in this one we call a double inequality because it's written, it's 2 in 1, basically. Okay? In other words, sometimes you may see this first one written as x greater than or equal to a, or x is less than or equal to b. You see, but we write it in an interval like that. It makes it simpler. Okay, how did we get the fractions out of our equations last time? That's the same too. Notice in this what we have to solve here, there is a 2 in the denominator that we need to multiply times both sides or all sides of my inequality so that it'll cancel. So when you have a denominator like that, okay, and you need to clear fractions, we're going to use that same skill of taking the common denominator multiplied through the entire inequality or equation or whatever you're solving. So I'm going to multiply all 3 sides by -2. So -1. Let me go back there. Excuse me. So we're going to have -1. And 2 is positive. Be careful on this one because, let me go ahead and fill all this in like this. If I had a negative value down there, you know, if I had to do that, multiply through by a negative, it would swap the signs, but this is positive, so my signs will remain. Okay, so we're going to go and multiply on through by this 2. Okay, by doing that, what's going to happen in the middle there is the 2's will cancel, and now I don't have a fraction. Now I just have the numerator, nicer version of the problem. Okay, and we have a -2 on the left there, okay? So here's what resulted from multiplying through the entire thing by a 2. Okay? Alrighty, so now we're working on getting x in the middle, right? Remember, we want to have something less than or equal to x less than or equal to something. So just like we did with equations, we're going to start by getting the constant term over to the other sides, 2 other sides. So 3 is positive, so I'm going to subtract 3 from all 3 sides. That's the big deal. And sometimes students kind of forget there's 3 sides to work with here. It's not hard, it's just something that's a habit. You got to not forget to do all 3. Okay, negative 5x less than or equal to, and then negative 6. Okay, and finally we're going to divide by a negative 5. Now remember, we're isolating x. Okay, so negative 5 here will give me just an x by itself in the middle. Okay, and so let me go ahead and put it in its own step. The reason I'm saying that is I want to change the direction of my sign now. Watch. Negative 5. Okay, and I'm going to write just the sides here. Okay. All right, so if I'm dividing everything by this negative 5, right, this guy, notice the whole thing got multiplied. Both sides, or all sides, got multiplied or divided by a negative value, so my signs swap directions. Okay. Now, let's go ahead and write our simplified version. Okay, so we'll have positive 1, right? These guys cancel. Positive 1. Now, greater than or equal to, and I'm going to have to write the direction a little differently in a minute. These guys have canceled, and I have x greater than or equal to positive 6/5. Okay, now leave it as 6/5. You can leave an improper fraction that's fully reduced for me. Okay, I'm fine with that. Okay, I have a question. 15. Where is that? 6. Did I make a mistake again? Where are we? Let me see. Oh, you're right. Oh my gosh. Yep, you guys, I got to go back. I did make I made an error. You know what? As we all know, I'm human. Sorry, guys. It's not quite possible for the computer to teach you all the way yet. Let me go ahead and fix it all. So look, work ahead. Now, okay, I'm going to fix that for you. Thank you so much for that. I appreciate that a lot. Let me see. Okay. Okay. And so let me go ahead and hurry up. And I'm going to catch us up really quickly. How about this? Yes, please, you guys. If ever I make an error, please, right away, correct me. It's fine. I'm proud of y'all. It makes me know you guys are listening. And so it's a good thing, okay? I'm not pride-filled, not the bad kind of proud. I'm really happy to have my students notice when I make an error. It's a good sign for an instructor. It should be a good sign for an instructor when the students catch the errors. Okay, so let's see, negative 5 less than or equal to negative 5x. Let's reduce 15. Okay, so we're good now? Okay, so now I'm going to divide by the negative 5. Okay, and so I'm going to have, let me go ahead and say, boom, negative 5. I'm just going to do this in one step. I've already kind of tried to do the other one. So, but I have to swap my signs, right? Because I've gone through by the negative 5. This is going to make this greater than or equal to. Okay, and so positive 1 x, and well, that's a nicer answer anyway, huh? Okay, negative 3. Now look, if you forget to swap your signs, y'all, look at what's happening. Okay, if it would have remained as less than, you would see that 1 is definitely bigger than negative 3, and the signs wouldn't make sense if you forget on this type of inequality. On the other ones where it's just 2 sides, you won't have the luxury of this. But when you have a compound inequality, it'll cease to make sense, or it'll be false. So you can go back then and catch your error if you forget to swap your signs. Okay. Now I said earlier we want to read these from left to right, and I'm still sticking to that. So look, here's what we're going to do. We're going to put the smaller number, negative 3. We're just going to take this whole thing and write it that direction. Okay, so negative 3 And you want the alligator to still want to munch out on the same, on the larger thing. So we're going to go this way. Okay? Now this sign, this direction swap is not the same as the last one. I'm just rewriting my solution, right? From left to right, I want smaller to larger because I have to do the graphical representation, possibly, -3 through 1, okay? And we want to shade in between here and use brackets. Now for interval notation will look like this: open bracket, all real numbers from -3 through 1, including -3 and 1. These three things, all three of these things say the same thing. They all represent the solution set. Okay, let's see. I'm going to go ahead and do this word problem. I have a couple of them. This is one that I have in here already. Let's go ahead and get into that. And then I'll do the absolute value inequality example really quickly. Actually, yeah. All right, so this will serve as my last example in this, to this effect, okay? So the velocity of an object fired directly upward is given by velocity is 80 minus 32t, where t is in seconds. When will the velocity be between 32 and 64 feet per second? So, okay, we have a representation, a formula, or you say an equation for velocity. So that's good. Okay, so the question, let's read the question part. When will the velocity, or v, okay, where's my pen? Okay, so when will v be between? We just saw between a solution that looks like that, okay? We can say x, in our previous example, x is between -3 and 1. Excuse me, my phone, my tablet just re-batteried, re-energized. And 1, and this is inclusive, right? Okay, so just kind of giving you an example, let's take that idea and come here. 32, well, velocity, we want to know when is it between 32 and 64. Okay, and it's just saying between, it's not indicating when is it that. Okay, so let's keep it as less thans, not or equal to's. So we have a statement that represents the velocity. So let's go with that, okay? Let's see. Instead of the v, I'm going to substitute in the statement for v, 80 minus 32. So let's write that, and that will be what we need to solve. Okay, 80 minus 32t. Okay, and then 46. So there are key phrases for each inequality, okay? And for intervals like this, it's the between or in the middle of, okay? I'm sorry, that keeps making so much noise. Stop, stop. Okay, so let's solve this. Now, hopefully while I'm trying to stop the noise, you guys can solve it. Go on ahead and solve it. Subtract 80 from all the sides. Remember, we're getting t in the middle. We start with the constant terms on all three sides, right? Okay. Oh, let me get my little solution thing. All right. So go on and do this. Let me get this myself. Okay. So this will be what, -28? Wait, hold on a second. All right. Hold on, I dropped my thing. I dropped my paper. Hold on, guys. You go on ahead and do this. I'm actually kind of giving you some time too. So, okay, I got it. All right. So anyway, so now we have what? -28 is less than -32t, less than -34. Am I getting something wrong? Let me see. Wait, hold on. Yeah. Okay. All right. Yes. All right. 32 minus 80. Oh, I got it. Okay. Yeah, that's right. Okay, we're going to keep going with this, though. Sorry, guys. I got turned around for a second. Okay, so now what do we want to do? we are about to get turned around, right? Because we're going to divide through by a negative value. What's going to happen, right? Sign swap. Divide by negative 32, all sides. Okay, so here is where we swap sign directions. We divide through by negative. So we have to go to positive, to greater than signs, okay? And so we will have positive 28 over 32. Okay, so let's see, 28. Most divisible by 4. Okay, so, oh, look, I'm writing on the wrong thing. I'm looking at the time, and I'm trying to get this done, so I'm sorry. So let's see, 4 into this is 7, 4 into that is 8. Okay, it's positive. I'm trying to hurry up and get your solution for you to 34 over 32. 34, 17, and 16. Yeah. Okay, 17 over 16. Okay, come on now. Sorry, guys. Okay. Okay, I still see like questions. Maybe I'm gonna put the hands down now, guys. Oh, I'm gonna put all your hands down, and because I have the hand thing keeps coming up, but I don't see anything new in there. So let's see. Okay. Textbook page 106. Independent question. Okay, can you type that number? Can you type that question in for me? Whoever's requesting that number 9, page 106. Can you type it in for me? Because it'll go quicker. So if it's typable, I'm not sure if you can do that or not. Otherwise, I may run out of time trying to keep it below the hour. I want to go through that. I can go over that. All right, look, let me finish with this, though. This is when the velocity, when the time after 7/8 of a second, and then 17/6, this is going to be what, 1 1/16 of a second. Between these amounts of time is when our velocity is between 32 and 64 feet per second. Okay? All righty. So let me move on from this, though, okay? I'm just going to let this be for a sec, okay, because I want to get on to something else that's equally as important. And Constantin, I know you want more word problems, but this is kind of important, too. Let me hurry up and give you this. We have about 5 minutes left. This is absolute value. We didn't get a chance really too much to go through this in a lecture, but before I leave, y'all leave here to right now, I need to go over this with you. Absolute value inequalities are also coming up. We talked about absolute value, okay, and I think we might have even done an absolute value equation, but I want to show you this. Absolute value inequalities. Let me get my notes open on that really quickly. All right, there you go. Okay, there's the setup. It's all in the setup with these, okay? All right, so here's how they're going to be set up. Okay, you're going to have the absolute, you want to make sure you have the absolute value of whatever it is, okay, and I can just call it mess, okay, because it can be a 3x plus 1 or whatever it is, it's inside of the absolute value must be isolated. Okay, if you have less than some number, okay, then, excuse me, if the absolute value is less than or equal to, the setup is this. You'll have negative a less than, take the mess out of the absolute value symbol, less than a. So in other words, here's an example of this, okay, really quickly. So if I have the absolute value of 2x plus 4, okay, is less than or equal to 3, for example. Here's the setup. This is for less than or equal to. Okay, we're reading it from left to right. Okay, so here's how this will go. We'll have negative 3. You put it into a double inequality. take the absolute value symbols away when you set it up like this, and you begin to solve it just like we have been doing. Of course, subtract 4 from all sides. I'm only subtracting, so don't do anything with your signs. It stays the same. So 2x, okay? And then, of course, divide by 2 on all 3 sides. Positive value, signs remain the same. Negative 7/2 less than or equal to x less than or equal to negative 1/2. You do want to always make sure 7/2 is definitely less than negative 1/2, especially when you have negative answers. You want to fool you. Be careful with that. Okay, so that's the setup for this. Okay, when you have your absolute value part less than a, or some real number. Okay. Now, the other one, if I have greater than, here's how that goes. Okay, quickly, very quickly. Here's the other version, and we're going to come in just right in time. Constance, I'm going to do a word problem right after this, okay? And I'm going to post it. I will get to do that today. I'll have a little more time. So let's have greater than. This is going to go in the other way, okay? The graphical of the first one I showed you with the less than, the answer will have an interval type graph solution, okay? This one is going to have the outer shading where we had something like that, okay? Okay, I'm not trying to scratch you out. So this is how this one will go, okay? So we're going to have negative a. Okay, so the mess, we're going to take mess out of the absolute value symbols, and it's going to be below the negative or above the positive, kind of outside. It's skewed from before. So the mess is going to be less than the negative of a, or the opposite of a. Okay, and mess is going to be above or bigger than the positive version of a, or as is a. Okay, so an example of this would be this absolute value. And look, let me show you something here. Here's what we can do too. We can have absolute value of, where's my pen? 2x minus 5. Okay, and let's do minus 1 greater than 2. Okay. Now, I have to make sure you isolate the absolute value part. Okay, so we want to get this by itself on one side. So I'm going to write the word isolate here. Okay, so isolate that first. So in other words, what we need to do first is add that 1. That's not inside the absolute value sign. See, these guys have to be by themselves. So we're going to add this 1 to both sides. Okay, so it'll cancel here. Now all I have is the absolute value part of the problem by itself. And that's what I need to be able to set the problem up into the 2 parts. So I have now the greater than 3. So I'm going to take this, what's inside here, just the inside of the absolute value here. That's going to get set less than negative 3, or and then in another part, which we solve separately, greater than positive. So here's that. So 2x minus 5 is less than the negative 3. Okay, and 2x minus 5 is greater than the positive 3. And you'll solve these independently, okay? So let's quickly go through this. So add 5 to both sides. Okay. All right. Quickly. I think we're going to run out of time. So x is less than 1. Add 5. Okay, we'll get the 8. The x should come in at 4. Okay. I'm going to let you guys fill in the middle of that, okay? All right, so look at this solution really quickly, okay? Okay, before graphically our solution, oh goodness, okay, our solution came in like this with negative 7/2, negative 1/2, X is between. X is above the bottom number and below the top number. It's equal to, we include these endpoints with brackets. Okay, here, this is what happens. Okay, we're going to exclude with parentheses, right? X can be less than the 1, so shade less than 1. And here's 4 here. X is greater than the 4. Here we are, and we use parentheses opened into that direction for that. The last thing I'm going to show you is the interval notation. Of course, the interval notation for the first solution would be the bracket 7/2, -1/2. This is going to be the last thing I do for y'all today. I'm sorry. Constantine, stick with me or stay tuned. I'll even message you when I put the example up. I'll do one more word problem. We're going to write -infinity through 1. Use the parenthesis. And for this one, right under it, let's write 4, infinity. Now this interval notation is representing sets. So to join two sets together, we use union. So this is saying the same thing as these things here. Okay, so this is one way to say it, another way to say it, and another way to say it. Okay, so these are all the same things over here too. And look, okay, so word problems coming up. Okay, I'm going to do that right now, but we have to end our webcast for today. You guys, thank you so much for the questions. I'm going to go back and look at your questions. I see the textbook independent practice number 9. I'm going to put all that in the short video. So I'm going to sit here and write all those down right now. So I'm writing it all down, and you guys have a great day. And look, you should be able to go view solutions for a couple of lectures now. The third one will be coming up soon. I need you guys to go in and practice. You know, that helps you get used to, it'll help you get much better at your mathematics skills if you go and check your work. So I'll talk to y'all soon. Be in touch, okay? 32 minus 80. Did I get one? Did I hurry up through and do that?